Alright, looking at this question, we want to provide the representation of the gauche conformer butane. I'm going to start this by drawing the simplest and most stable conformer butane, and I'm going to show it how we come about of it by bringing up on Marvin. Alright, so I'm just going to load in butane here, and it'll give us a nice little stick representation of it. Now, what I want to see is what the molecule looks like if we look straight along that bond between carbon 2 and 3. So I need to change this to that ball and stick mode and put it in a 3D axis. And now I'm going to grab the molecule. Oh, that's grabbing the whole molecule. I'm going to grab the whole molecule. I want to rotate it. I don't want that there. There. Come on. There we go. Alright. It was doing a drag. Alright. What I've done is I moved it so we don't see carbon 3. Carbon 3 is directly behind carbon 2, and we see that we have this nice straight line. And that's what we expect to see in the most stable form of butane. So how the Newman projections are done, go back over here. So we have methane. I'm going to do this in different colors. So I have CH2, CH2 to represent the metal. And at least on this first one, I have a CH3 that I'll put in that green and a CH3 there. So I have the 4 carbons in there. Now my Newman projection, I use a circle to represent those 2 carbons. And so we're going to have some things coming off the first carbon and things coming off the back carbon. Now I'm going to go back to Marvin to show what all these are, because Marvin doesn't draw everything because it's just carbons. And go back to 2-dimensional mode to show you what's going on. I'm going to add some chlorines to one of those carbons. And just to get different colors, I'll do bromines on the other ones. And to optimize that structure, and then I want to put it in 3 dimensions. And theoretically, yeah, alright, so looking along the 2 and 3, we see the carbons are still along a line, and the green ones, with respect to that one, are like 120 degrees from each other. And we're going to show that on our Newman projection. So this front location has 2 hydrogens, and it has that methyl. And then in the back, I don't have this going all the way center. That's why we can't see the full bond of it. Is that CH3 and then the other 2 hydrogens. Alright, now that Newman projection is exactly where we expect all the carbons to be if we're looking at butane in a nice little zigzag pattern. And if we do have a zigzag pattern for a longer molecule, we would expect the Newman projections to look like this along any of the bonds, where the carbons are as far away from each other as they can be with respect to that line. Now, name of this conformer is actually just called anti, sometimes staggered, but anti just means that they are opposed to each other, or they are anti-position to them. All right. Now, I have 4 other conformers. I'm going to do these all in blue, because what I'm going to do is I'm going to leave the front exactly where it is. And what I'm going to do is rotate that bond, that 2 to 3 bond, so these things in the back just move over some. So the very first one we're going to see is we're going to rotate this CH3 just enough to get it lined up with that hydrogen. So it is here. And this is rotated, so now this is a hydrogen, and the other hydrogen's there. So we've rotated the back just enough to get some overlap going on there. And since we're viewing this as that CH3 is directly behind the hydrogen and this hydrogen is directly behind that CH3, we call this one eclipsed. And I'll skip way over here because we have another eclipsed. So leaving the front exactly where it is, hydrogen, hydrogen, and that methyl. But what we're going to do to see this one is rotate this CH3 all the way down to the bottom, so it's overlapping with this other CH3. Therefore, this is a hydrogen, and this is a hydrogen. And the fact that those CH3s overlap, instead of just calling this eclipse, this is total eclipse. And the one here in the middle is just between those two, so the CH3 isn't here or here, it's right here. And my main CH3 is still there. So this is still hydrogen, this is still hydrogen, and right here is a hydrogen, and right here is a hydrogen. And this, where there's no overlap, but there's not fully anti, the two carbons are not as far away from each other as possible, is the gauche conformer.